Hello again. This is Dr. Chuck Desjardins. I'm going to be talking about the discussion question for Chapter 10 and experiments, more of a quantitative nature of information. So the discussion question is, using what you have learned in this week's readings, do some external research using the text and at least 3 outside sources and analyze the internal and external validity of an experimental design. So in a quantitative study, the question is analyze, that is, calculate, compare, contrast, criticize, discriminate, differentiate, question. Okay, the internal and external validity of an experimental design. So let's try and find an experimental design, and let's look at what we've learned in the text in this week about those things that affect internal validity and external validity. So what is internal validity and what is external validity? Well, internal validity is the validity of the experiment itself. So it is when the conclusions drawn about a demonstrated experimental relationship truly implies the causal effect or the correlation. So if I say there's a correlation between this independent variable or these two independent variables and the effect they have on a dependent variable, if that's true, then that's a valid internal validity. External validity is just saying, now that I've taken this information and I'm going to infer it onto a population, that the observed causal relationships can be generalized across persons, settings, and time. So that gives it external validity. What are some threats to internal validity? There is what's called maturation, the history, the testing that's done, the instrumentation, the selection process of participants, statistical regression, and experimental mortality. These are all threats to internal validity. History. During the time that an experiment is taking place, some events may occur that confuse the relationships being studied. If I'm doing research in an organization and it's a 3-week project and I'm checking the effect of an independent variable on a variable, maybe this group on an output, and something internally changes during that time, a new manager, a new office building, new information, it has an effect on the surroundings, it may affect my results. Maturation changes may also occur when the participants, through the passage of time, if I have an experiment that lasts a day long, and during that time the participant gets hungry, gets bored, gets tired, these conditions can affect the results, the effect that the X has on the Y, which is the independent, on the dependent variable. Testing is another one. That's the process of taking a test can affect the scores of the second test. If I want to know if this training is going to help someone's knowledge, which helps their skills, so I give them a pre-test. And I say, what do you already know? Then I do some training and I do a post-test and see, did this training make them understand more? Well, maybe that pre-test actually changed what they knew and understood, and it really wasn't the training per se, but the test, the pre-test, post-test had the effect. Those can affect the internal validity. Instrumentation is what I'm using to measure my results. If I have a measurement instrument, if I am looking at a clock, if I am looking at a scale and I'm going to weigh, we're making a change and I'm weighing something, well, the instrument that I'm using, is it consistently valid, or every time I weigh a same piece of material, does it get a little bit of different weight because the instrument isn't valid? Or the individual who is doing the weighing, do they know how to do the weighing? In product, it's called a gauge R&R, or measurement system analysis. It's understanding, is what I'm using to measure accurate and valid? Selection has to do, for internal validity, is a selection of participants for the experimental and control groups. You want to make sure that you have the samples that you pull from the population for both an experimental group and a control group are the same, and one doesn't get picked over the other, and therefore you bias the results. Statistical regression would be, this factor operates especially when groups have been selected by their extreme scores. So if we're picking the groups because of extreme scores in certain areas and there are 3 standard deviations out from the mean, we're going to definitely have an issue with between our experimental group and our control group. Experimental mortality means this occurs when the composition of the study groups change during the test. People can die off, people can come in and come out during that test. We start with 20 people in the experimental, 20 in the control group. 5 people fall out of the control group, we try and bring people in. So that's mortality of the experimental groups. Additional threats would be what's called diffusion of treatment, compensatory equalization, compensatory rivalry, resentful disadvantage, and local history. These all have to do with my experiment versus my control groups. The diffusion or imitation of treatment is if people in the experimental and control groups talk, then those in the control group may learn of the treatment, and that eliminates a difference between the groups. So you want to make sure there's no talk between the groups. Compensatory equalization is where the experimental treatment is much more desirable. In other words, it's much more desirable to be part of the experimental group because I'm getting training, I'm getting some benefits, I'm getting a great weekend to see how it affects my attitude at work, where the control group is just humping away at work. So that's called compensatory equalization. That could affect the control group's attitude. Compensatory rivalry is this may occur when members of the control group know they are in the control group. This generates competitive pressure. So they may try harder to get the results because they don't want to do as bad or be compared to the experimental group. Resentful demoralization of the disadvantage. That's when the treatment is desirable and the experiment is conspicuous. The control group members may become resentful that they are deprived and lower their cooperation. And local history means the regular history effect already mentioned that we talked about impacts both the experimental and the control groups alike. When one group assigned all experimental persons to one group session and all the control group to another, there's a chance for some peculiar events to confound the results. That's internal validity. External validity is how do I know that this group, the results, the causality or the correlation for this sample can be carried over into time, place, and event into another population. We've got what's called reactivity of testing on X, interaction of selection in X, and of course other reactive factors. Remember, external validity is concerned with the interaction of the experimental treatment that we did with other factors and the resulting impact on the ability to generalize that across time, settings, and person. I've got this experiment going on. I've affected people by this experiment. They're no longer part of the population they were. Now I want to say that this happened here and that whatever I did to this group would also carry with the group of the population, but that population didn't go through this treatment, which could have affected. So we want to be careful on external validity. Reactivity of testing it's called the reactive effect. That refers to sensitizing participants via pretest. So again, my groups have been sensitized, so it affected the results that we got, and therefore that same testing without pretesting in the external world may not apply. Interaction of selection will be the process by which the test participants are selected, and an experiment may be a threat to the external validity. So how did I choose my group? Is it really part of the population? When you hear of experiments that I pull from one small subset of supervisors, and now I want to pretend that applies to workers or workers to managers. We have to be careful how we take and we infer to the greater population. And also experimental settings themselves may have a basis on the participant response and therefore on the generalization. An artificial setting can produce results that are not representative of a larger population. I have an artificial setting that I may use in a laboratory, and to say I'm going to get the same results out in public may not be the same. Participants who know that they're in a research project may role play, and so it may not be the same as the population. And the interaction between the researcher and participants. So those are things to look for on external and internal validity of a research design. Thank you very much and enjoy the research questions.